Hi everyone, welcome to Rao's chemistry classes. In this video, I am going to explain one of the important organic basic concept, that is reactive intermediates. So what are reactive intermediates? How reactive intermediates are produced and how many types of reactive intermediates and what is the stability order of reactive intermediates? Each and everything in this video I am going to discuss very clearly. So this concept is a basic concept and this concept is very much important for particularly competitive examination like NEET examination and JEE examination, KSET, MSET, etc. Yeah. So what are reactive intermediates? Yeah, just look at the board. Actually, when you observe chemical reaction, reactants are left side and product is right side. But in between, one intermediate is there, that is reactive intermediate. Yeah. So reactants, product, in between intermediate is formed. That's the reason this is the definition. These are produced in between reactants and products. These are produced in between reactants and products. So this is the SN1 reaction. So when you look at the mechanism, you will get clarity. So this is the SN1 mechanism. Actually, SN1 mechanism involves two steps. First step, second step. Actually, in first step, when you observe very clearly, in first step you will get one reactive intermediate is there, that is carbocation. Actually, this is the direct question. What is the reactive intermediate in SN1 reaction? Answer is carbocation. How carbocation is generated like this? Yeah, this is the substrate. It is also called reactant. Yeah. So first what will happen? Carbon, chlorine. Chlorine is more electronegative. That's the reason electrons are shifted towards chlorine side. Then chlorine gets negative charge and carbon gets positive charge. C plus is nothing but intermediate. What is the reactive center in carbocations? C plus. Yeah. So next what happens? Second step. Second step, immediately reagent OH minus is nothing but nucleophile. Here nucleophile is immediately going to attach to carbocation and product is formed. And one more important point. Reactive intermediates are highly reactive. Highly reactive means highly unstable. So that's the reason we can say like that reactive intermediates are short-lived fragments. These are highly unstable. Immediately it converts into product. After formation of reactive intermediate, immediately it converts into product. That's the reason these are short-lived fragments. Yeah. So next, what are the examples of reactive intermediates? Reactive intermediates examples: carbocation, carboanion, free radical, carbene, nitrene, etc., etc. But out of all, examination point of view, carbocation, carboanion, free radical, these three very important. Yeah. So in this video, I am going to mainly focus on these three reactive intermediates. Yeah. Just look at the board. So name, what is the name of CH3 plus? This is called methyl carbocation. This is carbocation. Carbocation. This is carboanion. This is also called carbanion. This is methyl free radical. This is methyl free radical. Carbonium ion. Carbocation is also called carbonium ion. Okay. So number of electrons. So CH3 plus contain how many electrons? Just look at the board. Actually, this is the structure of CH3 plus. Just look at the board. So in our chemistry, one bond equal to 2 electrons. So here total how many bonds? 1, 2, 3. 3 bonds. So 3 into 2, 6 electrons. Yeah. How many electrons? 6 electrons. So what about this one? CH3 minus, same logic. 3 bonds. So 3 bonds bole to 3 bonds bole to 6 electrons. But you need to count these 2 electrons also. You need to add up this lone pair also. Then total it becomes 8 electrons. Next, what about this one? CH3 radical. Total CH3 is nothing but 6 electrons and 1 radical. Radical is nothing but odd electron species. Odd electron species are called free radicals. So anyhow, either 7 electrons. Actually, 7 electrons is called septet. Septet. 8 electrons is called octet. 6 electrons is called sextet. Okay. Everybody knows 8 electrons means octet configuration. Octet configuration means stable, whereas remaining unstable. So ultimately what I want to say is this is stable, these two unstable. Okay. Next, magnetic nature. So magnetic nature, very simple logic. That is, odd electron species have paramagnetic nature and even number species have diamagnetic nature. You just follow that logic. So 6 is nothing but even number. So even number is nothing but diamagnetic nature. Same diamagnetic nature. Same paramagnetic nature. Why? Because this is odd electron species. 7 is nothing but odd number. Okay, next hybridization. CH3 plus. CH3 plus is nothing but carbocation. Before that, I am going to give wonderful logic. All carbocations undergoes sp2 hybridization only. Fixed point. All carbocations, whether it is primary carbocation or secondary carbocation or tertiary carbocation or whatever, that is sp2 only. What is the hybridization? sp2. But when comes to this one, because of lone pair, this one sp3. So next, what about free radical? Except magnetic nature, remaining properties, free radicals follows carbocation rule. Anyhow, what is the hybridization here? sp2, like carbocation. Next, what is the structure of sp2? Trigonal planar. What about the structure of sp3? Pyramidal. Why? Because here 3 bond pairs and lone pair. That's the reason pyramidal. Same logic. This is also planar. Next, what about stability order? This is the stability order, TSPM. That indication 3 degree greater than, 2 degree greater than, 1 degree greater than methyl. So methyl carbocation, primary carbocation, secondary carbocation, tertiary carbocation. Out of all, which one is more stable? Tertiary more stable. Next, already I told you, free radical follows this one. That indication, this is also TSPM. This is also TSBM. So everybody knows carbocation, carboanion. So positive charge and negative charge. What is the relation? Inversely proportional. So hero को villain क्या होते हैं? Opposite होते हैं ना? Same logic को plus को minus opposite होते हैं. That indication you have to write reverse. So MPST. What is the order here? MPST. That indication methyl carbanion. Methyl carbanion is nothing but this one. This is stable, isn't it? Why? Because octet. Next, primary is nothing but 1 alkyl group is added. Secondary 2 alkyl group is added. Tertiary 3 alkyl group has added. Actually increase the electron releasing group, decrease the stability of carboanion. That's the reason this is the stability order. Yeah, just have a look. Very much important. Okay, next. So how to identify primary carbocation, how to identify secondary, how to identify tertiary, we'll discuss. Just look at the word. CH3 plus and CH3, CH2 plus, CH3, CH3, CH plus, CH3, CH3, CH3 plus. Yeah. So out of 4, which one is primary carbocation? Out of 4, which one is secondary carbocation? Out of 4, which one is methyl carbocation? Just look at the board. So what is the 3 degree carbocation? Carbocation is nothing but C plus. When C plus is attached to other 3 carbons, C plus को 3 other links आना चाहिए. बोले तो 3 कार्बन के साथ लिंक आया तो that is 3 degree. अगर C plus को 2 कार्बन लिंक्स आया तो that is secondary. अगर C plus को एक ही कार्बन लिंक आया तो that is primary. C plus को लिंक कुछ भी नहीं आया तो that is methyl. Just look at the board. So this is C plus. This one having how many carbon links? 1, 2, 3. That's the reason this is 3 degree carbocation. So what about this one? This is C plus. 1, 2, 2 links, 2 degree. What about this one? This is C plus. Only 1 link. That is this is primary. So C plus no links. That is this is methyl carbocation. This is methyl carbocation. Is it clear? Yeah. So out of 4, which is more stable? What is the stability order? This is the stability order, TSPM. That's the reason. Suppose this is 1, this is 2, this is 3, this is 4. Now you tell me out of 4 which is the more stable? This is more stable. So 4 greater than, 3 greater than, 2 greater than 1. But some of the students gets one doubt, sir, how fourth structure is more stable? How tertiary carbocation is that much stable? Let me explain very clearly. Just look at the board. Actually, this is the reactive center C plus. So reactive center is attached to alkyl groups. What are the alkyl groups here? Methyl groups. This is methyl group. This is methyl group. This is another methyl group. Actually, methyl group is nothing but electron releasing group. It is also called electron donating group. So actually here, increase the electron releasing group, increase the stability of carbocation. This is very much important. Very, very important. Increase the electron releasing group, increase the stability of carbocation. And one more important point, all alkyl groups act as electron releasing groups. This is a fixed point, to take it granted. Yeah. So, and one more important point, according to hyperconjugation concept, actually hyperconjugation बोल के एक concept है, electronic effects में आते हैं. Once you just go through electronic effects video in my YouTube channel, you will get full clarity. Yeah. Okay, so according to hyperconjugation concept, this is the C plus attached one alpha, C plus attached one alpha, C plus attached one alpha. So anyhow, in this particular structure contain how many alpha hydrogens? 3, 3, 3, total 9 alpha hydrogens. What about this one? This is alpha, total how many alpha hydrogens? 6 alpha hydrogens. When comes to this one act as alpha. Here how many alpha hydrogens? 3 alpha hydrogens. What about this one? There is no link, that indication no alpha, 0 alpha hydrogens. So what hyperconjugation concept explains? According to hyperconjugation concept, increase the number of alpha hydrogens, increase the number of hyperconjugated structures. That meaning increase the stability. So ultimately what I want to say is alpha hydrogens बढ़ गया तो stability बढ़ते. So increase the alpha hydrogens, increase the stability. So what is the key point here? This is the wonderful important key point. Just keep in your mind. So increase the number of alpha hydrogens, increase the number of alpha hydrogens, increase the stability of carbocation. This is also fixed point. Yeah. Just have a look. So out of all, which is more stable? This is more stable. Is it clear? Yeah. Out of all, which is more reactive? This is more reactive. Why? Because stability inversely proportional to reactivity. When C plus is attached to one carbon, that is primary. When C plus is attached to 2 carbons, that is secondary. When C plus is attached to 3 carbons, that is tertiary. Same logic, instead of positive charge, if you put radical, that is primary, secondary, tertiary radicals are generated. So ultimately what I want to say is, if you understand carbocations, then automatically you are going to identify which is a primary carboanion, which is secondary carboanion, which is secondary free radical, which is a tertiary free radical. Very simple, isn't it? Yes. Okay. Next, what about this one? CH3 like this. This is methyl free radical, isn't it? Yes. This is methyl free radical. What about this one? What about this one? This is benzyl free radical. Benzyl free radical. Yeah. So my question is, benzyl free radical is 1 degree or not? Yes, definitely yes. Why? Because C radical is attached to only one carbon. Actually this is carbon. Yeah. So C radical is attached to only one carbon. That is the meaning. This is the example of primary carbocation. This is the example of methyl free radical. What about this one? Suppose if I given like this, this is 2 degree free radical. So what about this one? This is 3 degree. Is it clear? Suppose if free radical, if I given like this, what will happen? This is primary carboanion. Instead of radical, if I write minus, what will happen? Methyl carboanion, isn't it? Yes. Key points for stability. Please write it down. First one, increase the electron releasing group, increase the stability of carbocation, increase the stability of carbocation. So reverse, second point is completely reverse. Increase the electron withdrawing group, decrease the stability of carbocation. So already I told you, carbocation directly proportional to free radical. So carbocation stability order, free radical stability order, both are same. Don't get confused. Next, what about carboanion? Completely reverse. What is the first point? Reverse. Increase the electron releasing group, decrease the stability of carboanion, stability of carboanion. So कभी भी देखो स्टूडेंट्स, नेगेटिव चार्ज आया तो ऐसा लोन पेयर लिखना पड़ेगा. वाई? बिकॉज नेगेटिव चार्ज इज नथिंग बट न्यूक्लियोफाइल, पॉजिटिव चार्ज इज नथिंग बट इलेक्ट्रोफाइल. या नेक्स्ट, व्हाट अबाउट फोर्थ पॉइंट? What about fourth point? Increase the electron withdrawing group, increase the stability of carboanion. Yeah, just have a look. Increase the electron releasing group, increase the stability of carbocation, increase the electron withdrawing group, increase the stability of carboanion. This is very important. Now some of the students going to get one doubt, sir, how to identify electron releasing groups and electron withdrawing groups? How to identify electron releasing groups and electron withdrawing groups? Yeah, I will give the order. This is the order of electron withdrawing groups. Electron withdrawing group order, main important points: NO2, Cn, C double bond OH, C double bond O, C double bond O, OH, fluorine, chlorine, bromine, iodine. All these are the main important electron withdrawing groups. Here NO2 is the strong withdrawing group. Next to Cn, like that. Is it clear? Yeah. This is very much important. Next, electron releasing groups. Electron releasing groups order, main important: NH2, OH, OCH3, C2H5, CH3, etc. Yeah, just have a look. This is the functional group. So here benzene का ऊपर कुछ तो भी functional group आया तो ऑर्थो मेटा पैरा पोजीशन पॉसिबल. ओनली बेंजीन को ऑर्थो मेटा पैरा पोजीशन नहीं आते, डोंट गेट कंफ्यूज्ड. सो अभी इसको ऑर्थो मेटा पैरा पोजीशन आते कि नहीं आते? डेफिनेटली पॉसिबल. सो दिस इज द फंक्शनल ग्रुप अटैच्ड कार्बन एक्ट एज ऑर्थो. Functional group attached carbon act as ortho. Functional group attached carbon act as ortho. Next carbon act as meta. Next carbon act as para. Same logic. Functional group attached carbon act as ortho. Ortho attached carbon act as meta. Next one act as para. So OMP, ortho meta para. Is it clear? Okay. So here important point, main important point, sometimes they are going to ask like this: out of 4 which is more stable and what is the correct stability order? Yeah. So if electron releasing group is attached, then you have to follow this order: OPM, ortho para meta, ortho having more stability. Yeah, CH3 is nothing but, here CH3 is electron releasing group. That's the reason you need to follow this order. Okay, now you tell me what is the correct answer. What is the correct answer? O is nothing but this one. This is ortho. So that's the reason. What is the order? What is the correct stability order for this one? First one greater than. Next P is nothing but this is para position. Third one. Next M is nothing but this one. Yeah, this one not having electron releasing groups. That's why this is the least stability. Yeah. So finally this is the correct stability order. Is it clear? Yeah. Sometimes they are going to ask electron withdrawing group. They will give electron withdrawing group like this. What is the correct stability order? Yeah, actually here NO2 is nothing but electron withdrawing group. If electron withdrawing group is present, you have to follow reverse order. OPM reverse MPO. You just follow reverse MPO. Are you getting my point? Yeah. So NO2 is nothing but withdrawing group. So what is the answer? M. Where is M? Yeah, this is meta. So what is the order here? What is the correct order? M is nothing but third one. M. Next to P. P is nothing but fourth one. O is nothing but this one. This one, second. Yeah, but here you need to understand one important point. Initially we have discussed one point. Electron releasing group increase the stability, electron withdrawing group decrease the stability. So here not having any group, that indication here withdrawing group is there, that indication these three having little bit less stability compared to this one. That's the reason you need to write a first one initially. So 1 greater than, 3 greater than, 4 greater than 2. This is the correct answer. Are you getting my point? Yeah. Carry on. These 2 points very much important. Okay. Next. Sometimes in examination they are going to ask stability order for carboanions, stability order for free radicals. Already I told you, free radicals directly proportional to carbocation, no doubt. So when it comes to carboanion, you just apply reverse order. Simple, yeah. Once again, so what are the main key points? Till now, what key points we have discussed? What key points we have discussed? First point, increase the electron releasing group, increase the stability of carbocation. Yeah. Next, second point, increase the electron withdrawing group, increase the stability of carboanion. Next, number 3, increase the electron withdrawing group, decrease the stability of carbocation. Next, increase the electron releasing group, decrease the stability of carboanion. Yeah. Next, electron releasing group for carbocation stability order is OPM. Electron withdrawing group stability order is reverse, MPO. This is for carbocations. So what about carboanions? Electron releasing group, electron withdrawing group, completely reverse. Carboanions, MPO, OPM. This is for carboanions order. These are very important. Next important point, increase the plus I effect and increase the plus M effect, increase the stability. So ultimately what I want to say is plus I effect to plus M effect to directly proportional to stability. But the plus I plus M, दोनों में which is more stronger? Plus M is nothing but resonance effect. Resonance effect is much stronger than inductive effect. You need to apply this point also. Sometimes this point also useful for you. Nothing goes wasted. This point also useful for you. What is the main point? Resonance effect. Resonance effect is much stronger than inductive effect. Okay. Next, randomly I am going to ask some questions. Try to give the answers. Out of 3, which is more stable? Based on key points, try to give the answer. What is the correct stability order? So I am giving 30 seconds time. Try to give the answer. NO2 is nothing but withdrawing group. NO2 is nothing but electron withdrawing group. Electron withdrawing group. So OCH3 is nothing but electron releasing group. Electron releasing group. Yeah. So this is carboanions. When it comes to carboanions, this is the order. This is the carboanions order. Yeah. Electron withdrawing group आया तो carboanion का stability बढ़ते. So that indication, second one is more stable than first one. Next, third one. Why? Because the third one is nothing but electron releasing group. Increase the electron releasing group, decrease the stability of carboanion. Is it clear? What is the stability order? Actually, this is very simple. Why? Because this primary free radical, this is secondary free radical, this is the tertiary free radical. So everybody knows TSPM is the order. Then what is the answer? What is the correct stability order here? Very simple. 3 greater than 2 greater than 1. This is very simple, isn't it? Yes. So let me ask you one question. Out of 2, which is more stable? CH2 double bond CH, CH2 plus, and CH3, CH3, CH3 plus. Actually this is 3 degree carbocation, this is 1 degree carbocation, isn't it? Yes. But my question, this one and this one, out of 2, which is more stable? I am giving 1 minute time, no problem. Try to give the answer. If you give correct answer, that indication you are the most brilliant student. Definitely you are going to crack NEET and JEE. Allyl carbocation and tertiary butyl carbocation, out of 2, which is more stable? So most of the students yeah. So out of 2, which is more stable? Most of the students answer is this one, but practically this is more stable. So let me explain very clearly, don't get confused. Actually this is primary carbocation, I do accept. This is a tertiary carbocation, I do accept. Actually when it comes to order TSPM, that indication tertiary, secondary, primary methyl. But here one logic is there, that is this one undergoes resonance. Why? Because the double bond, single bond, positive charge, conjugation possible here, conjugation is there. Conjugation is nothing but resonance. Just have a look. CH2 double bond to CH, CH2 plus. Suppose if I shift this bond here, what will happen? It will get like this, CH2 plus CH double bond to CH2. Yeah, these are resonating structures. So here resonance possible. Resonance possible. Already I told you resonance effect is much stronger than inductive effect. That's the reason, because of resonance this is more stable. Is it clear? This is very important. So out of three, which is more stable? What is the correct stability order? Carry on. First you need to identify which one is primary, which one is secondary, which one is tertiary. Then you will get clarity. Yeah. So this is the reactive intermediate, isn't it? Yes. C plus is attached to only one link. That is the reason this is primary. So what about this one? C plus is attached to only one link. This is also primary. C plus is attached to only one link. That's the reason this is also primary. Are you getting my point? Yeah. Here three structures are primary only. Then what should we do? We have to follow this logic. Increase the number of alpha hydrogens, increase the stability. Then find alpha hydrogens. This is a C plus attached carbon. This is alpha, but actually here no hydrogens are there. That's the reason 0 alpha hydrogen. So C plus attached carbon act as alpha. Alpha having only one hydrogen. That's the reason here one alpha hydrogen there. C plus attached carbon act as alpha. So here how many alpha hydrogens are there? 2 alpha hydrogens are there. What is the logic? Increase the alpha hydrogens. Increase the stability, isn't it? Yes. Then what is the correct order? What is the correct order? Which structure contain more stability? Third one, second one, first one. So finally this is the correct answer. Carry on. Next, I would like to give one important point. Just look at the board. So this is 3-degree carbocation. Generally 3-degree carbocations are highly stable, isn't it? Yes. But what is the logic here? This is highly unstable. Why? Because this is bridged head carbocation. क्या बोलते हैं इसको? Bridged head. This is bridged head carbocation. Bridged head carbocations are highly unstable. Highly unstable because of ring strain. This is also very much important. These are highly unstable. Highly unstable. Very important point. Yeah. Next, what are the main points? Increase the resonating structures. This is also important. Increase the resonating structures. Increase the stability. Increase the resonating structures. Increase the stability. Sometimes they are going to ask like this. Try to understand the logic. This is also example of primary carbocation. This is also example of primary carbocation. But out of two, which is more stable? So how to decide? By using this line. What is the statement here? Increase the resonating structures, increase the stability. Actually this is benzene ring. So benzene ring undergoes resonance. This one also undergoes resonance. But practically this one gives more resonating structures. But when this one gives only 2 resonating structures. That's the reason this is more stable. Are you getting my point? Yeah. Try to find the answer for these two. This is carboanion. This is carbocation. So here one logic is there. CH3, CH3. Here also CH3, here also CH3. So here what is the CH3? Electron releasing group. Here also electron releasing group. But what is the difference? This is carbocation, this is carboanion. Yeah, I am giving 1 minute time. Try to give the answer. If you give correct answer, that indication you are the intelligent student. Yeah. Carry on. So what about first one? First one is carboanion. So carboanion means increase the electron releasing group, decrease the stability. That indication fourth one having more stability. Next, MPO. M is nothing but this one. P is nothing but this one. O is nothing but this one. Yeah. Cross check your answer. Next, what about this one? Increase the electron releasing group, increase the stability of carbocation, Next OPM is the order, that in OPM, O is nothing but this one, first one, P is nothing but third one. Yeah, this is the correct answer. Okay students, so carbocations, carboanions, free radicals successfully completed. So this is the reactive intermediate concept. This is very important. You have to practice well. Okay, so each and everyone, please subscribe my channel. This is very useful for you. Whoever looking for NEET examination 2023 and whoever looking for JEE examination 2023, whoever looking for MSET and KSET and remaining sets, this video is very much important. Please subscribe my channel. If you like, you can like it. If you want to share, you can share to your friends. Bye for now. See you again.